Hey guys, welcome back to the Philco 90 restoration project. When we last left off, we finished restuffing every capacitor, Bakelite blocks, metal cans, tone control. Since then, I replaced all the resistors, and I'd like to pass along a few tips and tricks I used to make this happen. One of the issues I encountered is that the leads were not long enough to go from one lug to another. Partly because the lead lengths aren't as long, and partly because the physical resistor bodies are much shorter. And in the case of this guy, no problem. But for this one, I needed to go from this lug over to this lug. It just wasn't quite long enough. And I realized, hey, on each one of these main lugs, there's actually a smaller lug where the internal capacitor is attached, or in this case, this one had no internal connection. It was just unused. Sort of figured, what the heck, I'll wrap the resistor lead around that lug, and just that little half-inch was all I needed to have the resistor fit. Other cases wasn't quite so simple. The worst one I encountered is this resistor down at the bottom. I needed to go all the way from this lug on a Bakelite block to a lug on the power resistor at the bottom of the chassis. The new resistor wasn't anywhere near long enough, so I needed to extend leads. A few ways to do it. One is to leave as much of the old lead as you can. I'll talk about that a little bit later. The other is to attach a new extended piece of wire to it. Simplest way to do that is to do a J-hook. So here is my new resistor. Take the end of it and do that, make a J. Take some bus wire or strip some wire, get the insulation off. Do the same thing on that. Hook the two together, crimp it, and solder it. And then cut two lengths. The idea being that you want to create both a strong physical bond and then solder it. And then cut this off to whatever length you need and then hook it together. Other way, it's a little bit more secure, is to do a pigtail. To do that, you're going to need a small diameter rod of some sort, maybe even a sturdy component lead if you have one. But I also noticed that this new tool I got for poking out Bakelite blocks works fairly well for it. So take your component lead or your new piece of bus wire, whichever is more convenient, put it on there and wrap it around and make a corkscrew. And then cut it if you need to, trim it up a little bit. This is a little bit large diameter, so I'm going to kind of crimp the coil a little bit. Slide that over your component lead. Crimp it down even more so it's really in there securely. And then solder it, and then cut this to length as needed. So those techniques are fine when you've got a cleaned off lug that you can wrap your component lead around. But in some cases, you don't want to disturb the old components and the old wiring. For example, here we've got a trimmer cap, and there's a mica cap, and there's a resistor in parallel. I want to replace this resistor. I don't want to stress off these other components. I don't want to mess with them. So what you can do is cut off the resistor and leave the leads behind. Now in this case they're pretty short. If they were longer, you could do the J-hook on these. Bend these leads over into a J, take your new part, make J's on the end, link them up, solder it. In this case there's not much there. So this time, instead of making a corkscrew on my bus wire, I want to make a corkscrew on my resistor itself. So I'll take my component lead, hold it on there, and wrap it around. I'll do the same on the other end. And just squeeze it down. There are actually, I believe, some purpose-made tools for doing this. I think they call these squibs. You can also fabricate one yourself fairly easily with an X-Acto knife, of all things. I haven't tried doing this myself, but I read about it. The idea is, instead of a blade, take this out. And it works better on the type of X-Acto knife that's got 4 sections rather than 2. But you'd put a small diameter rod down the center like a knitting needle and drill a tiny hole into one of these pieces up top. And the idea is you stick your component lead into that tiny hole and then wrap it around the knitting needle and then slide it out and you're done. If I did this more often, I would definitely make a purpose-made tool for it. But with the small amount of this I do, I just kind of wing it a little bit. So I trimmed up, or I am trimming up my little squibs here. Kind of angle them around, and then you slide them over the remains of the resistor leads. Crimp it a little, bend it around, and then do the same on the other end. I'm going to cut this a little short, but I can make it just barely. Alright. Crimp that one and solder it up, and you're good to go. And that puts no stress or strain on the old joints. Maybe it doesn't look as nice and neat, but it's pretty quick and doesn't mess with your alignment or damage the wiring or anything like that. And you don't have to mess around with a solder sucker and desoldering braid and all that fun stuff. And it's in there very securely. It's not going anywhere. Basically, the key is to do both the mechanical sound connection and then solder it on top of that rather than just relying on the solder to hold it in place. So that's what I did all the resistors. So we're almost done. I'll do an alignment next. I've already done it by ear a couple times. I don't suspect that things are going to change a whole lot, but I'll quickly run through it. And then the speaker. I'll show you the state of the Philco 90 speaker I picked up. It's not going well. So I think I will try to rig up the Philco 20 speaker I've got, because it has the right plug on it, to at least make some sound. And maybe I can continue on with that for now until I get the Philco 90 speaker working, which I don't expect to have done anytime soon. So we want to try using this Philco speaker with a push-pull output transformer designed for a Model 20. Ideally, I could just plug this in and it would work. We almost can. These 2 back pins, which correspond to the 2 top pins here, are the field coil. That matches up. Problem is the bottom 2. This one's unused on the radio chassis. That's okay. But what we want to do is ignore the center tap and use the outer 2 windings on the primary. Here's the situation we've got. Only 3 connections are used. Those are the dots. And one side of the field coil is going to one side of the primary. The other side of the primary goes to the plate on the output tube. Okay, well, what does the speaker have? Well, here's a schematic for a Model 20. Pretty basic radio. It's not a super hat. It's TRF, I believe, with push-pull 71A outputs. So on this, the little circles and squares there, those are the speaker connections. So there are the two field coils. Problem is, one side of the field coil on this does not go to one side of the primary. It goes to the center tap of the primary. And then the outer two sides of the primary go to the plug. So what can we do? Nothing without opening up the speaker a little bit, because we've got to disconnect the center tap. I mean, theoretically we could try. So if I hook this up now, what would it do? It would use 1/2 of the primary. The impedance would be wrong, would be underutilizing the primary, the turn ratio would be wrong, we'd be losing some output power, I believe. Or there'd be too low of a resistance, we might be pushing the output too hard, because the turns ratio of primary secondary, if you decrease, cut the number of primary turns in half, that means the output voltage would double, right? I think I got that right. Alright, so we need to, if we can just disconnect that center tap, I think we'll be alright. And then we'll take the 4 pins we've got, and we can modify this plug a little bit, short 2 of them together. Otherwise, inside the speaker, we can take, say, this, and short it to this. Short these two together, and disconnect the center tap. Okay, I got the 2 1/4-inch sheet metal screws out of the transformer, and I was able to pull it away a bit. Turns out that there are terminals on the transformer itself, so the wires that come through the speaker harness go through this grommet around the top, and the 2 field coil wires come over, and all essentially the transformer acts as like a terminal strip, so all the connections are made on it. And I have determined that this is the center tap. That's one side of the primary, the other side of the primary is down here. So if I take the field coil wire, which is that black greenish one back there, and move it from that to that, I think that'll do it. And to remember to never plug this into a type 20 radio, or bad things would happen. So let's give it a whirl. Okay, surgery is complete. No more bodged in transformer, no power resistor for the field coil. We've got the real deal hooked up. Potential problems, well, output impedance might not match too well, and this is designed for push-pull, not Class A. Class A, single-ended output, constantly has current running through the primary. So it could become saturated at high volume levels. Let's see what happens. I'll put this into current mode in case something really goes wrong. That's on. Let's listen for a crackle. Haha. We have sound.
You jump through hoops when you want to withdraw your winnings. If you haven't signed up yet, we'll give you $100.
That's a strange sound. It's very tin can, echoey sounding. But I'll take it.
Or eye fatigue. Wouldn't it be nice if there was something that could read for you in an instant anything you're now missing? Well, there is. The OrCam Read. This is incredible.
See, when the tone control disengaged, it kind of sounds like it's engaged.
And can promise you it's easy to use, and most importantly, it works.
In other words, not the greatest fidelity.
The OrCam Read is the size of a...
Chicago.
Chicago's most trusted stop for updated news minute by minute. News Radio
It's muted, I guess you could say.
105.9 FM.
Now with a look at things to do around Chicagoland this weekend, here's WBBM's Rachel Pearson.
The theme is Halloween this weekend, starting with the ongoing spooky spectacle over at Navy Pier. Check.
That's another.
All right.
Schedule your free consultation today.
So no more hacked-in crap. I'll go with that for now. That sounds fine to me. I'm not going to be looking for high fidelity out of this thing.
A better basement
Cool.
starts with us. Medicare is complicated.
Meanwhile,
Medicare is no
when I get around to it and get a better workshop set up, I'll work on that other speakers. I think I really need to get a vise or something set up to try to whack that pole out to rewind it. But I will do a little bit of work on this because this wiring is crazy brittle. Or at least in some points it is. It's not too bad in the middle, but clearly it's cracked and frayed here. I didn't wrap this tape around, somebody else did.
To protect her home and family in a disaster, Karen
Or
was
maybe I can get away with
wade
sliding
through
heat treat
water,
tubing over it.
And insurance paperwork.
I don't know.
I can do this.
I can see it's cracked. I mean, that's a common failure point right where it joins up. And I'll try to find some music and see what that sounds like. Weak station, so it's not going to sound that good no matter what.
Yeah, Brian had not
I'm stepping away for the workbench and sitting in front of my computer for a little bit to show you some of what goes on behind the scenes. So in addition to this YouTube series, I've also been posting a restoration diary on the Philco forum, and I've gotten lots of great advice and tips, suggestions, and so on. Specifically, this has to do with the speaker. This is where originally I got the lead on buying that Philco 90 speaker. Unfortunately, we know it's got an open field coil. And I've tried unwinding it. I have not found the break yet. I'm giving up on that. I've unraveled so much. The whole thing just needs to get rewound now. Problem being, one, getting the thing apart, and two, magnetic wire is pretty expensive. Upwards of 30, 40 bucks for a 1 pound roll. But I got a tip. Seller in Wisconsin selling 36 gauge magnetic wire, 1 pound for $9. We don't get a whole lot of detail about it. We got this photo that looks a little bit thicker than 36 gauge to me. And then that, well, for $9 plus $7 shipping versus say 40 bucks plus similar shipping, I figured I'd give it a chance. It just arrived earlier today, and yeah, it looks promising. Now, how did I know the gauge? Partly, again, from research, asking on the forum. I'm not 100% certain it's right. Might be 35, might be 37, but it seems like that's the right ballpark. Okay, how much do I need? Well, I know what the DC resistance is supposed to be, right? But I didn't know how much resistance there is per foot, and or at least, sorry, I can find the resistance per foot. Okay, but I don't know how long it's supposed to be, and I don't really know how much it's supposed to weigh. So only two things I know is it's about 36 gauge, and it should be about 3,400 ohms DC resistance, I think. Okay, so where can we go from that? Well, I hunted around and I found some folks who give me the parameters I need, in particular this guy. So he's also selling 1 pound for $23. And he tells me the length is 12,381 feet. Awesome. And also that it's 466 ohms per 1,000 foot. And that resistance does vary a bit with temperature. So it might be a little more, a little less. But another source said more like 400 ohms per 1,000 foot, but you know, we figure we're in that ballpark. Okay, so we can do some math. We need 3,400 ohms, and it's about 400 ohms per foot. How much do we need? All right, here is a handy-dandy calculator. I believe we need 3,400 ohms, and I'm going to go with 400 ohms per 1,000 foot because I saw that at several other websites. It varies with temperature. This is about what I saw for room temperature, or thereabouts, per 1,000 foot. So if we do that, we get multiply that by 1,000, 8,500 feet. And if he's saying a 1 pound roll is over 12,000 feet, I've got plenty. So we need to get this thing apart. Okay, I say bash because I'm jumping ahead because I also found a thread in the Philco forum about how to repair the field coil. And this guy went through and did it with a minimal of tools. Some 2x4s, a hammer, and such, and some acetone to dissolve the glue holding the cone in place and so on. I'm going to try doing what he did. So nothing fancy, just some ingenuity and some brute force. So we'll give that a try. On another front, I've been looking for a good replacement for the volume control. We wanted half a mega ohm or 500K, audio taper, 3/8 inch bushing, 1/4 inch shaft of decent length, and some nice solder lugs would be a good thing. I finally found one made by CTS. They've been around a long time. They make good stuff. 2-inch length shaft. It's fully round. We can file it down to the Philco knob, cut it off to length. Fantastic. 2-watt rating. That's plenty. Only issue is it's $26 at DigiKey, but I did a little more hunting, and at Mouser Electronics, $17.76. So I ordered one up. For something that gets used so much, I'm willing to spend a premium to get a good, solid quality control. I'm happy that somebody still makes these, because it's the most heavily used control, typically, after the tuning knob anyways, and they're so often replaced. I've got so many radios, or seen so many, where there's something hacked in there. It's not the right wattage, it's not the right value, it doesn't have the right feel to it. So that is on the way. It will arrive on Monday. All right, finally alignment time. I did one earlier by ear, now we're going to use some test equipment. Unfortunately, there are no alignment instructions with the Philco service info I have. Just a schematic, parts locator, parts list. But in the Rider's compendium of service info, there is a little section on the Philco 90, just the stuff. We've got a diagram showing key locations for things to adjust, and then a little chart telling you what to adjust. Right now we're doing steps 1, 2, 3, which involve injecting a signal up here into the grid of the detector tube, the mixer tube I should say, also known as the first detector. It is a 175 kilocycle AM modulated with about 400 hertz, connected via a 200 picofarad capacitor they refer to as a dummy antenna, and the ground goes from the RF generator to the chassis. Now there's a lot they leave out of this little diagram. For example, it says to adjust it for output signal max. Output signal where? Using what? Well, to fill in those blanks and explain this in more detail, I'm going to direct you to a video by Mr. Carlson's lab, where he does a video just on this very topic, how to interpret those old-time alignment instructions and filling in the blanks for stuff that they assume that you know. Well, a common way to get the output, to check the output, is across the voice coil of the speaker, which is low impedance, so you could use a volt-ohm meter like a Simpson 260, you could use a VTVM. I'm going to use a scope because I happen to have one handy. Now, something else they don't tell you is what type of signal to inject. Yes, we know the IF frequency is 175 kilocycles or kilohertz, but it needs to be AM modulated in the audio range, because we're looking at the detected amplified output, the audio output. If there's no modulation, there's no output, there'll be nothing to measure. So we have this set to be AM modulated. I think it's 400 hertz. 175, RF level out. We've got the level all the way down because we're feeding this right into the radio, so we need a pretty low level signal. We want to inject just enough signal so we can hear it and see something on the scope. And I've got the volume control up all the way. I'm using a scope because I just happen to have been given one recently and I cleaned it up and I want to play around with it a little bit. So let's time the level on the RF generator and see what we can see and hear what we can hear. Alrighty, that's pretty weak. Or we can go down a little bit more sensitive on the scope. That's the most sensitive range right there. The scope doesn't trigger that great, so ignore the wobbly waveform. We want to adjust points 1, 2, and 3 so that it gets as tall as it can be, as large as it can be. And as it gets larger, assuming it does, assuming our alignment is off, we should decrease the level on our RF generator so we don't overload the equipment or our eardrums. Now there are holes in the chassis. This is point 1. There are trimmer capacitors accessible to the top. You need a plastic tool. Chassis is metal ground. The capacitor has voltage on it. You don't want to short the two together. So we will use this, and we will adjust this. And hey, look at that, and hear that. It's getting louder. The waveform is getting larger. So the alignment was off quite a bit. So before I did this by ear, and I don't know what frequency it was on. I just tuned into a radio station and adjusted it so it was the loudest. I clearly was not doing it to the right IF frequency. That's the problem if you don't use test equipment. You're going to be aligning it to the wrong frequency. What's the problem with that? Well, the radio will work. We'd obviously have heard stuff, but the radio is optimized to have the greatest efficiency at 175, so that's what we're going to use. Ooh, oh, that was way off. And every time we get that peaking so it's off the screen and it's getting too loud for our ears, we lower the level on the RF generator. Alright, there's one more on the back of the chassis. That one wasn't off too much. So what we're doing right now is we are aligning the IF. Let me go through and do it again. The steps after this are about aligning the RF portions. Don't worry about the noise, that's just my raggedy old scope fan, cooling fan. Alright, cool, that should help. We're definitely off. Alright, next I will go through and do the RF sections. It's similar, you just connect the signal in different places, and I'll complete the steps. I'm not going to bother filming it because I think it's kind of boring for you to watch because you really have no idea what I'm doing. The point is we're injecting a signal at certain points, and we're adjusting what it says to adjust so we get the maximum output. Well, that's going to be it for this installment. I'm going to go through the alignment one more time while I'm not filming so I can focus on it a little more. And we'll pick up when the replacement volume control has arrived, and we'll tackle that Philco 90 speaker, and then start thinking about putting this all back together in the cabinet.